Welcome to this tutorial on transformational geometry, which will cover translations, rotations, reflections, and dilations. To demonstrate these concepts, we will use a Cartesian plane to show movement and a triangle, which we will manipulate using transformations. Let's start with translations. Translations mean that a point is being moved across the x or y axis. There are two factors that must be specified in all translations: the movement on the x-axis, i.e. left or right movement, and movement on the y-axis, i.e. up or down movement. To show this, we'll call the points that make up the triangle A, B, and C, with A at 1, 1, B at 5, 1, and C at 3, 3. We will translate the points -3 units on the x-axis and -4 units on the y-axis. This puts A prime at -2, -3, B prime at 2, -3, and C prime at 0, -1. Next up are reflections, which are the creation of an image of a point with reference to a given plane, such that the point and its image are the same distance from the plane. Reflections must have a line of reflection, which runs through 2 points. For example, let's put our triangle back in its original position. We then make a line of reflection that runs through points -1, 0, and -2, 0. We then count the distance from each point and find a point that's equidistant on the other side of the reflection line. This puts A prime at 1, -1, B prime at 5, -1, and C prime at 3, -3. Rotations are when a point is moved in a specified direction, most commonly clockwise or counterclockwise, to a specified extent, most commonly 90 degrees, 180 degrees, or 70 degrees, around a certain point. With the triangle reset, we will rotate it 90 degrees clockwise around point 0, 0. This puts A prime at 1, -1, B prime at 1, -5, and C prime at 3, -3. Finally are dilations, which are the enlargement or shrinking of an object to a specified degree around a certain point. The variables for dilations are the point of dilation, where the point is being dilated, and the scale factor, or how the object will be affected in all directions. We will dilate the triangle around point 2, 0 with the scale factor of 2. This leaves A prime at 2, 0, B prime at 10, 0, and C prime at 6, 4. A common usage for transformational geometry is in aircraft design. For example, reflections are common on aircraft wings, as shown here. This ensures that the aircraft is structurally stable and has improved drag and stalling characteristics. Another usage of transformational geometry is in maps, which are often dilated by a certain scale factor. This is to make these maps small enough to be usable, but still provide a scaled-down representation of the distances between certain locations. Finally, house-cleaning robots like Roombas often use rotations and translations for movement across rooms by using sensors to plot out obstructions on a Cartesian plane and then calculating the ideal route to take. This helps them avoid going to the same location multiple times and improves efficiency. Thank you all for watching, and see you all next time.
Created using Powtoon.